Welcome back. In this video, we are going to talk about another function, cumulative distribution function. Before that, in the last class, we have seen about probability mass function, which can be represented as P suffix capital X of small x as the probability of the event x equal to small xi, where I equals to 0, 1, 2 up to so on. The probability mass functions can be put in a table where you can see the probability distributions. I am going to consider the same example, toss a coin twice, where the random values are 0, 1 and 2, and their probability mass functions. Probability of 0 is probability of getting 0 heads. Probability of 1 means probability of getting 1 head is 1 by 2. Probability of getting 2 heads is 1 by 4. This is called a probability distribution. We can put the PMF of values of a random variable in a table, that is called a probability distribution. Now let us see other function, cumulative distribution function. CDF. This is represented with capital F suffix capital X of x. I always says that the probability is always applied on an event. In this function, the event is x less than or equal to small x. Apply probability on this. This probability of the event is called cumulative distribution function. So we can define it as the probability of an event x less than or equal to small x is called as cumulative distribution function, CDF. We can write the probability of x less than or equal to small x as, here the upper limit is, we can see this x as upper limit, lower limit we don't know. So whenever we don't know the lower limit, we can take it as from minus infinity. So we can write this cumulative distribution function as sum of the probabilities at x equals to minus infinity plus up to so on, plus x equals to 0 plus x equals to 1 plus up to so on, plus x equals capital X equal to small x. It is up to x. Cumulative means the values are added one by one. So the probabilities are added one by one up to x equals to small x. This is cumulative process. The probabilities are added in cumulative. So we can write the CDF as the sum of probability mass functions. Sum of probability mass functions. Simply let us put as of now CDF is the sum of probability mass functions. Simply I am writing so probability of mass functions. Now let us consider the same example. Toss a coin twice. Toss a coin twice. where we have seen the random value 0, 1 and 2 and their probability mass functions are 1 by 4, 1 by 2 and 1 by 4. So this is the distribution function. So probability distribution of this experiment. For this let us find out CDF. So fx of 0, let us apply the formula. It is the probability of x less than or equal to small x. Here small x is 0. Okay. In this case, the range of the random variable of this experiment is from 0 to 2, 0, 1 and 2. To the left of 0 and to the right of 2, all are impossible. If I consider minus 1, minus 2, those values are outside 0, 1 and 2. And if we consider 3, 4, 5, even positive infinity, those are also outside the range of the random variables. Those probabilities are always 0. Now coming to here, probability of x less than or equal to 0, we can write it as a probability of x equal to 0. Because of 0 to the left of the 0, there is no defined value. We have only three values, 0, 1 and 2. So probability of x less than or equal to 0 is probability of 0 only. So it is 1 by 4. Next, capital Fx of 1 is nothing but it is the probability of x less than or equals to 1. Now it is the sum of probability of x equal to 0 plus probability of x equals to 1. We are adding the probabilities at x equal to 0 and at x equals to 1. So previous value, probability of x equal to 0 is a previous value, probability of x equals to 1 is present value. So we are adding previous values to the present values. This is cumulative addition. So probability of x equal to 0 from the given table, it is 1 by 4, and probability of x equals to 1, it is 1 by 2. So this value is 3 by 4. And next, fx of 2 is nothing but probability of x less than or equals to 2. It is nothing but probability of x equal to 0 plus x probability of x equals to 1 plus probability of x equals to 2. It is nothing but probability of x equal to 0 is 1 by 4 plus probability of x equals to 1 is 1 by 2 plus probability of x equals to 2 is 1 by 4. It is 4 by 4. It's nothing but 1. Let us write all these. Let us write fx of 0, it is 1 by 4, and fx of 1 is 1 by, it is 3 by 4, and fx of 2 is 1. Fx of 2, x less than or equals to 2, it is considering or it is taking all values, means it is a sum of probabilities of an experiment, nothing but it is sample space only. X less than or equals to 2, it is covering 0, 1 and 2. So the sample space consists of 0, 1 and 2. So simply whenever you are finding x less than or equals to maximum value of a random variable, this is always 1 only. Now let us plot this. Let us plot this where x and y axis is fx of x CDF. Now the values are 0, 1 and 2. So CDF fx of 0, the CDF value at 0 is 1 by 4, and this is maintained to the next random value. This 1 by 4 is maintained to the next random value, Now we are at x equals to 1. At x equals to 1 we are going to add x equals to 1 with the previous value. So at x equals to 1, 1 by 4 plus 1 by 2, it is 3 by 4. It is 3 by 4, and this 3 by 4 is maintained up to x equals to 2, and the CDF at x equals to 2 is 1. And what after 2? And what before 2? What is CDF before 0 and what is CDF after 2? Before 0 and after 2, the values are impossible. The values are impossible. The probability of impossible events or impossible values are always 0. This is CDF. We are adding the probabilities cumulatively. The CDF at 2 is 1. It is already reached 1. After 2, the probabilities are 0 and we are adding 1 with 0. 1 plus 0 is always 1. So after 2, the probability CDF is always 1. And what before 0? What before 0? These are always 0, because these are impossible values or impossible events. The probabilities are 0. Even you add 0 with 0, it's always 0. This plot is a staircase. The plot of CDF is staircase and it is increasing. So staircase. Second one, it is increasing function. The plot is increasing. If we consider this as x1 and this as x2, x1 equals to 1 and x2 equals to 2, where x1 less than x2, and the CDF at x equals to 1 and the CDF at x equals to 2, if we consider, and this is it is increasing function. So when you consider x1 less than x2, then definitely the CDF at x2 is greater than CDF at x1, because it is increasing one. The plot is increasing one. And coming to minus infinity, let us consider x equals to minus infinity, and let us consider x equals to plus infinity. Now let us apply the CDF fx of minus infinity. So x equals to minus infinity, it is outside the range of the random variable. The probabilities are 0, and even you add zeros with zeros, many zeros, is always 0. So the CDF at minus infinity is 0. And coming to x equal to plus infinity, this is fx of plus infinity. The CDF up to positive infinity means it covers all the random values. It covers all the random values. So you are going to add all the probabilities of all these values. It's nothing but you are considering all the sample space. You are considering total values in the sample space. So it is always 1. This is always 1. Now if you see this staircase plot, you can treat this as addition of unit steps. What I am saying, this and this and this, these are all addition of unit steps. steps. So we can write this fx of small x, which is nothing but probability of x less than small x, as summation over I probability of at x equals to xi. We are writing as a function of probability mass functions u of x minus xi, u of x minus xi. U means here unit step where xi equal to 0, xi equals to 1, xi equals to 2. So you can write the CDF as a sum of probability mass functions using step function. It's okay. Now let us see the properties of CDF. Properties. The first property, fx of minus infinity 0, just now we have seen. Second one, fx of plus infinity is always 1. Third one, the CDF is always bounded by 0 and 1, and the fx of x1 less than or equals to, not less than or equals to, it is less than only, it is less than fx of x2 if x1 less than x2. So this says that CDF is an increasing function, and another one, the probability of x1 less than capital X less than or equal to x2, it can be written as the CDF at x2 minus CDF at x1. Another one, the probability of x equal to small x is nothing but PMF. The PMF can be obtained from the CDF as capital Fx of x minus Fx of x minus. X minus means the value before x. X minus is nothing but value, random value just before the value x, just before value x. If I say x plus, it is a random value just after x, and fx of x plus, if it is equals to fx of x, this says that it is right continuous at x equals to small x, and fx of x is equals to fx of x minus, it is left continuous at x equals to small x, and fx of x minus is equals to fx of x plus, then it is continuous on both sides, at x equals to small x. So these are the properties of CDF. Let us obtain the PMFs from the table. This is CDF plot 0, 1 and 2. Same example I am taking. This is 1 by 4, 3 by 4, and this is 1. Now I want to find PMF at x equal to 0 using CDF. It is nothing but fx of 0 minus fx of 0 minus fx of 0 minus fx of 0 minus. So which property we are using? We are using sixth property. This property we are using. Probability at x equals to small x equals to CDF at x minus CDF at x minus. Now see the plot, and CDF at x equal to 0 is 1 by 4, and CDF of 0 minus. So 0 minus it is 0. So it is 1 by 4. Next, the PMF at x equals to 1, just apply the formula fx of 1 minus fx of 1 minus. So this is fx of 1 minus means fx of 1 minus means just the random value just before 1 minus. So what is the value there? 0. 0 is just before 1. So fx of 1 is, what is fx of 1 value? It is 3 by 4 minus fx of 0 is 1 by 4, it is 2 by 4, it is 1 by 2. Similarly, the probability mass function at x equal to 2 is nothing but fx of 2 minus fx of 2 minus. So fx of 2 minus, what is the value just before 2? It is 1. 1 is just before 2. So fx of 2 it is 1 minus fx of 1 is 3 by 4, it is 1 by 4. So this way we have to find a probability mass function, or we have to find a probability at x equals to some values from the CDF plot. And we are going to write the CDF function fx of x. If we consider Rx, x0, x1 up to some xn, a random variable x which have the range from x0 to xn. This can be written as 0 for x less than x0. The CDF is always 0 to the left of x0, and it is 1 for x greater than the maximum value of range. What is the maximum value of range? This is maximum and this is the minimum. Okay, so whenever you are considering a random variable greater than this maximum value, it is always 1. These are fixed. Whenever we are writing CDF, first we have to write 0 and 1, the CDF 0 and 1, and their intervals we have to write. And in between there may be 1, there may be like this x0 less than or equals to x less than or equals to xn. This one we have to find. what is the CDF in between x0 and x1. And there may be multiple intervals, x0 to x2 and x2 to x4, x4 to xn. Multiple intervals are there, and we have to find what is the CDF in those intervals. But we have to keep in mind that whenever we are writing CDF, we have to keep in this 0, in which interval this is 0 and in which interval it is 1. First we have to write those. Thank you.